1.2, here we come. So we're talking today about expressions. We're talking about evaluating expressions, additive inverse, absolute value. It's all things you've seen before, although absolute value, not a super lot if you only had Algebra 1. If you had Algebra 2 or geometry last time, you already got another dose of learning about absolute values. Tuesday, when we see each other again, the 5 answers I'm about to put in these 5 boxes, one of which is already there, those are the answers you need for a Tuesday quiz. So I think you know by now, we've encountered this in even elementary school probably. You're allowed to use letters to represent numbers. That's a thing. Okay. What are those called? When you have a letter that represents a number, most often. Those are most often called variables. So the Tuesday quiz, I'll ask you, what's a variable? And you can tell me it's a letter that you use to represent a number. Not all letters are variables. So here's a thing with a bunch of letters in it. Not all of those letters are variables. Can anybody spot which one of those in here is not a variable, actually? R? No, the R is a variable. The A is a variable. So by process of elimination, the pi is not a variable. So now that we know that answer, can anybody tell me why is pi not a variable, but A and R are variables?
A's and R's could be any number, but pi is already a number.
That is correct. The R could be literally any number in the world. The A could be any number in the world. Pi is pi, 3.1415. There's no changeability to pi. So not every letter is a variable. There are some letters that are sometimes called constants. But I don't want to belabor that point. But physics class, when you get to physics someday, if you get there, there's a bunch of different constants involved in physics for different equations and things. Can anybody tell me what this is for? It doesn't really matter to your life right now, but what does this do? What math thing even is that?
Isn't that to find the area of a radius?
It's to find the area of a circle. Circle. So if you have a circle, the R stands for its radius. A circle could have any radius. It could be 3, 4, 10, a million. Any radius could happen, any positive number could happen for a radius for a circle. The A, the area, comes by doing some math with that. Doing math with the radius, getting pi in there, you get the area. We're not going to do that today. But that's just there to illustrate. Letters can represent numbers. If it's an unchanging number, that's called a constant. But most of the time, you're going to encounter variables that can just represent whatever. Expressions. Up on our board, I have a couple expressions. We're going to write some expressions over there. Can anybody tell me anything about what an expression is? Because come Tuesday, after question 1 asks you what is a variable, question 2 will ask you what is an expression. Does anybody have anything to chime in on maybe what an expression is? What it has in it?
Variables.
It can, okay, it can have variables in it, that's true. Let's try this side question. Can anybody spot me on the board an example of an expression? This is not correct. That's something else. That would not be an expression. Somewhere on my board, there is an example of an expression.
Is it that thing at the bottom of the board?
What is it?
Is that an expression?
Where are you looking?
Oh, it's like below where we're supposed to put it.
Like, read me what you're reading.
It's like 2 times 4, 3g or whatever.
2x plus 3y?
Yeah.
Yeah, I would agree with you if that's where
I
you're
don't
looking.
have, I'm not the best.
You're in the way back. I get it. That's fine. 2x, and I don't write the best. So dangerous combination of guy in the back and my handwriting. But 2x plus 3y, that's an example of an expression. That does have variables in it. It doesn't have to have variables in it. There are other expressions up here that don't have variables in them. But it could have variables. What else could it have? And in fact, it does have. Numbers can be in there. Signs. So an expression is just a combination of numbers. I don't care if you spell out numbers. I tend to abbreviate numbers with in my day that was called the pound sign. In your days, that's now a hash mark or hashtag. numbers, variables, signs. So this has numbers, variables, and signs. That is an expression. Right here, that's an expression. So is this, so is this, so is this. I guess so really even are these. Those are not very big expressions, but those still would count as expressions. They have numbers and some signs. But some combination of numbers, variables, signs is expressions. Why did I say no on this? Why is this not an expression?
There's no like, there's no numbers on this?
Well, there sort of is numbers, and there sort of are letters, and there sort of are some signs, but this gets a different name.
It has an equal sign.
Has an equal sign. So that's no longer expression land. What is that called when something gets an equal sign dropped in it? Equation. So equal sign stuff, those are equations. If you have something that looks like an equation, but you can't find an equals around it, that's kind of another way I guess I can explain expressions. I think the first bit of homework will ask you to evaluate an expression. So if I said to you, 2x plus 3y is my expression. Oh, by the way, x is 5, y is negative 7. I would like for you to evaluate that expression. What do I have in mind for you to do? What does that mean if I say evaluate the expression 2x plus 3y if x is 5 and y is negative 7? What's your job?
Like plug in.
Yeah, put the numbers for the letters and then do the math. So I'm going to say to evaluate an expression means to replace variables with numbers and then do arithmetic. If you don't like the word arithmetic, say math, that's fine, it's a good synonym. But just replace the variables with their numbers and do the math that shows up. So if we replace this x with a 5, this little bit of math here creates a 10. If you don't trust yourself to remember 10, write it down. If you trust yourself to remember 10, just remember 10. If you put a negative 7 in for this, if you put negative 7 in for the y, what's 3 times negative 7? Negative 21. If you go to adding one positive number with one negative number, what is that going to do for you? Positive 10 adding negative 21. That is negative 11. If it's a giant chore for you to come up with negative 11, you might, I don't want to be mean, but you might not be really like ready for Algebra 2. Okay, Algebra 1 spends a lot of time just working on how to add numbers like that. General math would spend a lot of time adding numbers like that. And here we kind of take for granted. I'll remind you, when you add one of each kind of number, the sign gets determined by the bigger number and you subtract them. That's why that's negative 11. But if that's not a thing you're sharp at, you might need to sharpen that up somewhere else. But evaluating expression, question. Third topic, we'll ask you to do some additive inverses. So I could ask you to do the additive inverse of negative 3. Yesterday that came up. You had a property of additive inverses, and we kind of had that conversation a little bit yesterday. If I ask you to do the additive inverse of negative 3, a thought on what that is?
Positive?
It is positive 3. A thought on either a synonym for that or an explanation of what in the world we just did. Opposites. Okay, so additive inverses are sometimes called opposites. So I could ask you, find the opposite of negative 3, and you shoot back positive 3 in the same way. That's true. A thought on what we did?
If you add a negative number to its positive self, it will always be 0.
That's true, but that's more detail than we want to go. I'm just looking for a basic answer of how does a human being do an additive inverse? I give you this, you give me back that. What did you do in the meantime?
Change the sign.
Change all the signs. So an additive inverse just means to change all the signs of something. It's sometimes in our book, they will do this with words and say, what is the additive inverse of this number? It's more often that they're going to do this just with symbols and punctuation. Does anybody know how, another way I could show you that I'm doing the additive inverse of negative 3, and you give me back 3, but I would only use symbols to do it and none of the words. The words get replaced with symbols.
absolute value, so.
No, absolute values are going to do a different thing. They aren't going to always change signs. They like sometimes change signs and sometimes don't.
Multiply by a negative?
That's true. How could I show that? Parentheses. And a negative out front. That would be correct. If I write this, or if I write this, I am doing the same thing. This means switch the sign of -3. This means switch the sign of -3. Those mean the same thing. The book tends to do this. So if I wanted to find the additive inverse of this, I would be unlikely as an author of a book or a typer of a test to type out, find me the additive inverse of this thing. I'd be much more likely to just go like that. And that's telling you, find me the additive inverse of that thing. What would be the additive inverse of this thing?
-2x
-2x
plus 3y
plus a 3y
minus 4z.
minus a 4z. Again, your job is just change all the signs. Question about additive inverse life. Absolute values. A thought on either how to do some of these questions or what absolute value means or is or does or what it's about. Go ahead. It's the distance from zero. The absolute value of a number is just its distance from zero. So you give me back that answer on Tuesday, I'm happy. So just a quick recap. Quiz looks like, what is a variable? 1. What's an expression? 2. How do you evaluate an expression? 3. How do you do an additive inverse? 4. What is the absolute value of a number? 5. You do that, you're 5 for 5. Put in some time, go 5 for 5. Sometimes people will say absolute value is always a positive number. Why is that a lie to say that absolute value is always a positive number?
Is 0 positive?
Because 0 is not a positive number. You can do an absolute value and get 0 if you started at 0. Other than 0, absolute value answers are always positive. But 0 is not a positive, and sometimes 0 gets discriminated against and forgot. But yeah, absolute value, not always positive, but we could say almost always positive. 0 is the only special case. But absolute value of 4 would make 4. The absolute value of -4 is also 4. We're just trying to measure positive number distances from 0. If I go like this, what's up?
Negative.
It is -4. This negative was not included in the bars. The bars will zap anything inside and take away all the signs that are found. So on a problem like this, the bars are going to zap anything inside to make that +4, but that's outside the bars. That would not get zapped. So this would produce us a -4 for an answer. Question about that little trio? Here, if I go 8 minus 3,
5.
and then I hit the bars, it is 5. The bars act like parentheses, by which I mean what?
You do that first.
Do that first. Anything in the bars gets done first. So 8 minus 3, do it first. You're thinking 5, the bars just leave it 5. If I go like this, and I insert a negative there, I stick a negative on the 8. Is that still 5, or is this a new thing? It's a new thing. What new thing is that? It's now 11. Because if you have -8 and you subtract 3 more, what are you down to? -11. And then the bars makes it an 11. 3 minus 8.
Also 5.
That is also 5. 3 minus 8 temporarily forces you to think of -5, but then when the bars take over, it's +5. What if I go like that? Now it's back to the 11. Because we went down to -11, we came back to 11. Question about those with the what ifs? If I lost you before this was there and before that was there, those were 5s, before the 11s happened. Now that I did those, they're 11s. Something there on the rewind. This one,
5.
5. The bars take effect, and this 8 is really 8. And the 3 is 3. And then you subtract last because the bars weren't involved in the swallowing up the subtracting. That's just going to be 5. If I make this change,
Still.
do I need my eraser? No. Because the bars zap that into 8, that's still 3. 8 minus 3 is still 5. I go like that. Did I change anything to the answer? No, because it's still zapping that into 8, it's still zapping that into 3, it's still going to subtract to make 5. It's just a question of if the bars surround the problem, do what's in there first. It's easier for me to change those. If the bars are not surrounding the like add subtract thing, you don't get a whole lot of variation on life. This one is negative 5. The bars leave that in 3, the bars leave that in 8. After you're done thinking bars, 3 minus 8 is negative 5. Would that change anything? No. Would that change anything? No. Okay. Don't try to do, you've got from past days the idea that if I give you a subtract problem like this, that subtract problem makes who? 7. Because you've been learning from people for a lot of years probably that minus minus, like make that a plus, that's a thing you've seen. That does not apply when bars get in the way. Bars get in the way of that, you can't go minus minus making plus, the bars are running interference for that. You can't, it's not a thing. So don't go on hitting on this and be like, oh, minus minus makes plus. No. The bars are in the way, you've got to do the bars like the parentheses and do the bar stuff first. Question about that? So this is not making the quiz. The only way you'd see this again is if this made like an extra credit question somewhere along the line. Every math book in the world will do this definition for absolute value with symbols only. I have one over there that I was using words for you. I'll take the words one on Tuesday. That's what I'm good with. But every book has this in it. Your book has it in it. The geometry book, you've seen this. The Algebra 1 book, you've seen this. The question is, when you do an absolute value, like what happens? And there's a two-part scenario. So what's one scenario? If you do the absolute value of certain types of numbers, what's one thing that can happen to those numbers when you do absolute values of them?
They stay the same.
They stay the same. So sometimes you do the absolute value of x, and you just get back x. That's only true under certain circumstances. Can anybody tell me what the circumstance is? Or tell me what to do if it's the other like option. Okay, if it's positive. I'd rather use math symbols than that word. So how could we describe that x is positive? What does that mean?
Could you do x greater than 0?
X greater than 0. X greater than 0 is like a more math symbol-y way to say it's positive. So if x is greater than 0, you just leave it alone. To do the absolute value of a number, you leave it alone if that number is more than 0. That is true. That's not the only scenario though.
What, less than 0?
Less than 0. Okay, so if x is less than 0, there's a second choice. And every book will put this little squiggly bracket around the 2 levels just to kind of let you know we could do 2 different scenarios here. What do you do if x is negative? It becomes positive. How can I tell you that a negative x is becoming positive? How can I show you that with symbols? We already did it once today. Yeah, we could, and since it's a single thing, you don't even need it in parentheses, but it wouldn't hurt. But we do throw in front a negative symbol. This doesn't mean that the number is negative. This means that the number is opposite what it was. Like when we did our additive inverse conversation, when I wrote a single negative in front of one thing or a group of things, it just meant we were switching them. The example we did with the 2x, 3y, 4z. Some of that was positive and it became negative, but some of it was negative and became positive. This would just be read to do the absolute value of a number, leave it alone if that number is more than 0. Switch its sign if that number is less than 0. And that's 95% right, and I wouldn't give you your extra credit point because we discriminated against somebody. 0. If you had 0 itself, does it need switched or just need left alone? Left alone. How do we include 0 in this level then?
You put the line under the.
Greater than or equal to 0, and now that's perfect. That's the least important thing that's on the board today. But if you followed that, great. If you followed that, you're learning more to express symbols, to express ideas instead of words. You like words. You use words your whole life since you were born. You don't like math symbols as much. Only your math teachers make you use those. But it's a good skill to be able to take an idea that's words and somehow make math symbols. It's a thing you'll do on and off through the year. Final chore is debatably the easiest chore. Maybe not for everybody, but for more people than not, I would think that's true. You're going to be asked to write some expressions. So they're going to give you a whole lot of words, and they're going to say, do this with symbols only. So 5 more than a number. Can somebody give me back an expression with no words?
5 plus x.
5 plus x. What if somebody else said x plus 5?
Still right.
They're still right. You can add in any order, it doesn't make any difference. More than is a code word that you want to add. If that's news to you, maybe jot it down. And I'll give you 2 more that you could jot down, but I know these and I'm not going to write them down. But more is an add word. What's another add word from like 7th grade days gone by? Increase is an add word for sure. What's the answer called when you add?
Sum.
Sum. So if you see more, increase, or sum, something like that. Difference. Different club. What's difference about?
Subtract.
Subtract. What else is subtract?
Less than.
Less than? Difference?
Decrease.
Decrease. Those are our subtract friends. I want the difference of 2 numbers.
X minus y.
X minus y would be fun. How about x minus x? No. Different. 2 different numbers. We want to go different letters. Let me rewind back to this one. If I go 5 less than a number, 5 minus x,
Gotta flip it.
gotta flip it. Only less than makes you do that, but the phrase less than makes you go in the opposite order. I don't know why, just trust me, take it by faith. It's just how it happens. If you're 5 less than something, it has to be something minus 5. It just is what it is. Toward the end of the homework, you might get challenged by a couple because they're doing multiple things. So both of these have products, threes, absolute values, and numbers. But I tinkered with the order of the question, so it tinkers with where the symbols go. Like, these were not the same question. Where the bars went made those different, but we're off camera, that's okay. Back over there, camera people, you remember what it was. Absolute value, I tinkered with where the bars were placed, it made things different. So anybody a thought on product of 3 and the absolute value of a number, how that might look different than the absolute value of the product of a number of 3?
Because you're moving with a.
Well, go ahead, just give me like what you think the answer would look like.
See, okay. In the absolute value symbol, for one would be 3, and then times like x, and then the other one would have x in the absolute value symbol.
So who's in the bars for this one?
3
3?
times, like out of the bars now, right? Times x.
And you want the x there?
Yeah.
Okay. I'm not agreeing or disagreeing. Did you have an opinion?
I would go 3 out of the bars and x in it.
So these go in that for that one. What would you do for this one?
Then for this one, so then it would be 3 times, it would be like 3x in bars.
The whole thing?
Yeah.
So choice A, choice B, choice C. Somebody else weigh in. We have differing opinions. You gonna change your mind on yourself?
Okay, so could you reread the one that I'm supposed to answer?
So this one was the product of 3 and the absolute value of a number. This one was the absolute value of the product of a number and 3.
Yeah, I'm pretty sure Joseph.
Okay, so you retract your answer?
Yeah.
Okay, so he's backing out on his. Somebody else weigh in? B, C, you liking those? You want to create a new answer that you think he's wrong and you're right? There's 18 of you, one person weigh in. You like it, you don't like it. Okay, Nicole weighs in, she likes it, I like it as well. If you don't see the phrase absolute value for a while, the absolute value only is going to surround the stuff that comes after it. So when they say product, you got to multiply, it says 3, you get a 3 in there. Oh, there's going to be an absolute value, but only of the number. That means the x is going to go in bars, because that's what followed the word absolute value. This, it says find the absolute value of, it's like, uh-oh, bars are going to surround everything that's coming. After the absolute value phrasing, we've got product of 3 and the number, so the 3 and the number both go in, and then you wrap it all up.